All right, here we are, folks. We're going to solve this system of equations using substitution. If you are doing this online and not live with us, you should pause the video and give it a shot yourself. So I'm going to use the hint here, which is to take all of this, because it equals y, we can take it and we can substitute it in for y in the other equation. So we have 6x plus 2 times the quantity, and that's how we read it when we have something in parentheses, negative 3x plus 5, and that all equals negative 4. So that's how we're going to use the substitution method to solve this, because now we only have x terms, which is great. We need to distribute this 2 to everything inside parentheses. So we have 6x, and then positive 2 times negative 3x is negative 6x. 2 times positive 5 is 10, equals negative 4. Now what I notice is that my 6x and my negative 6x, those are like terms, so they can be combined. But when I combine them, I get a 0x. So this simplifies to 10 equals negative 4. Does 10 ever equal negative 4? There should be a resounding no. Everybody all at once, turn your mics on and just say, no, Mr. White Wolf. Wonderful. 10 never equals negative 4. So what is our answer here? Anybody? No solution. What was that, Mia? All right. Does it make sense, though, what I did? All right, sweet. Great, great, great. So now, what does this mean when we have a system of equations and we get no solution? What does that tell us about the two equations? Don't tell me about the graph. Tell me about the equations. It tells us that there is no xy coordinate pair that will make both equations true. That's what no solution means. There's no xy coordinate pair that will make both equations true. But now we're going to graph these same two equations. And I'm going to start with the y equals negative 3x plus 5. So on my graph, I have the y-intercept is at 0, 5 right there. And my slope is negative 3, which says go down 3 and to the right 1, down 3 and to the right 1, and continue on with that pattern. We can also go up 3 and to the left 1. So we have a point there. Now we can connect those with a line. Make it as straight as you can. Mine's pretty straight, not super straight. The points there help, though. Hey, River, glad you're here, man. Now we're going to graph this 6x plus 2y equals negative 4. And the way we're going to do that is we're going to plug 0 in for x to find the y-intercept and 0 in for y to find the x-intercept. So let me make some room here. So we're going to find the x-intercept first by plugging 0 in for y. So we have 6x plus 2 times 0 equals negative 4. So that makes 6x equals negative 4 because this makes a 0. Now we divide by 6 and we get x is equal to negative 2/3. So that gives us the point. X is negative 2/3, Y is 0. So negative, and I'm going to do those in red. Let me change the color on that. That one's going to be red. There we go. So that gives us this point. X is negative 2/3, Y is 0. So about, whoops, about right there. Pretty close. All right. Now we're going to do the same thing. I'm going to make myself a little bit more room by making this smaller. We're going to do the same thing. We're going to find the y-intercept here. And let's use a nice purple. The y-intercept by plugging in 0 for x. So we have 6 times 0 plus 2y equals negative 4. This becomes 0, so we have 2y equals negative 4. And now we're going to divide by 2 in order to isolate our y value, and we get y equals negative 2. I should have used a color. I'm going to use purple on this. I'm going to make all of this purple. And although I like to have different colors for my steps, I'm going to do purple because I want my point to be in purple here. So the point that I get, x was 0, y is negative 2. So x is 0, y is negative 2 is right there. And so if I just connect those points and then extend that line as straight as I can, looks about like that. And what do you notice about those two lines? And maybe it's not perfect, but what do you think is probably true about them? They're parallel, Jojo. Exactly. And why does it make sense that they are parallel? Yes, beautiful. So, because when we did the algebraic solving and we got no solution, it makes sense that we have parallel lines because if they crossed, there would be a solution. So good. Anybody have questions on this warm up? Beautiful. Tell Lucinda to watch the video and she'll hear her name now in the video. How exciting will that be? So example 1 here, and you should be taking notes. I think these notes are in your packet. Does anyone have their packet there with them right now? It's possible they're not. You have one? Are these examples in your packet? They might not be. Okay. If not, you can just do them on some of the blank paper at the back of your Naomi says they're not. So go to the blank pages and take your notes there, please. So can anyone guess, or not guess, what variable are we going to eliminate here? Yep, that's great. Oh, you don't have your packet, Naomi. Gotcha. Okay, Mia. Thank you. Can anyone tell what variable we're going to eliminate here? The x's, yeah. In the first equation, we have a negative 4x, and in the second equation, we have a positive 4x. So if we add those together, we're going to get a 0x. So what we're going to do, and this is the way that I show it, I put parentheses around the whole equation and say that we're going to add that whole equation to the first equation. So when we do that, we add the negative 4x to the positive 4x, and we get a 0x. Of course, I don't need to write 0x there. Next, we add negative 2y to the positive 8y. Again, we're adding it. So we get 6y. And then our equal signs come down. And then we're taking negative 12 plus negative 24 is going to be negative 36. Questions on step 1? All right. Now we have 6 times y is equal to negative 36. The inverse operation of multiplication is division. So we're left with y is equal to negative 6. Now we've found our value of y. Now we need to find our value of x. And we can use either one of these two equations. It doesn't matter which. So I'm going to take the first one, not for any particular reason. So I have negative 4x minus 2 times negative 6 equals negative 12. So what you should notice is I used this equation and I plugged the negative 6 in for y right here. Now we have the negative 2 times negative 6 is positive 12. So we have negative 4x plus 12 is equal to negative 12. To undo that operation of adding 12, we subtract 12 from both sides. So we have negative 4x equals negative 24. Now we have to isolate the x by dividing by 4. And we get x is equal to positive 6. So then our answer is x is equal to 6 and y is equal to negative 6. And we have a coordinate point for our solution. Now, if we wanted to check that, then we would go back and we would plug 6 in for x and negative 6 in for y in both equations and see if they come out to be true. They need to come out to be true in order for that solution to be correct. Are there any questions? Okay. Now on this one, we added the two equations together. On this one, we are going to subtract the two equations. Can anyone see why we would subtract here instead of adding? Well, if we did add, we would get a negative 1x plus 2y equals 5. And we haven't eliminated anything. Okay, so, however, if we subtract, so notice here I'm subtracting this entire equation from the first equation. So if we subtract, we get x minus a negative 2x. Well, subtracting a negative is the same as adding, so that's 3x. And then we have a positive y, subtract another positive y. That's a 0y. But I don't need to say 0y. And then we bring our equal sign down. 1 minus 4 is a negative 3. So notice that I have to consider this negative, this subtraction outside of my parentheses each time. When you're subtracting, that's what you have to do. Are there any questions on that first step? All right, to isolate x, we need to divide by 3, and we get x equals negative 1. Now, again, we can use either of our two equations. I usually try to see which equation seems easier, simpler. I think that one does. So we have -1 plugged in for x plus y equals 1. To isolate my x, or excuse me, my y, I need to add 1 to both sides because that will make a 0 there, and I will get y is equal to 2. So my solution is x is -1, y is 2. It's a coordinate point. When I plug -1, 2, this turns out to be true. That's obvious. When I plug in -1, 2, well, let's see. This is +2 plus 2 is 4. So they both turn out to be true. Am I frozen still? When I solved the whole thing, I was frozen? Okay. Does it make sense as you see it right now? All right. Are there any questions? Yay for technology, huh? Okay, so on the first one, we saw that we can add two equations to eliminate a variable. On the second one, we can subtract one equation from the other to eliminate a variable. On this one, there's something else we can do. Why can we not add or subtract here? What's the problem? Yeah, so if we add, then we get 12x minus 2y equals 16. If we subtract, we get 4x minus 2y. I might have done my addition wrong last time there, equals 6. All right, so in either case, we don't eliminate anything. In this one, we can multiply the whole equation by something so that we can eliminate our x's. Does anyone see what we can multiply by? What do I need to multiply this by so that we can eliminate our x values? 2. 2 or -2. Either one works. So I'm going to keep this equation exactly like it is, all right? And then I'm going to take this equation and I'm going to multiply it by, I like to add my equations. That's what I prefer. So if I multiply by -2, I'll get a -8x plus 6y equals -10. I have to multiply each part. 4x times -2 is -8. -3y times -2 is +6y. 5 times -2 is -10. And now, when I add my two equations together, I get negative, so this makes a 0 when I add 8x plus -8x, that makes a 0x. -5y plus 6y is +y equals 11 plus -10 is 1. Now I'm going to take that and I'm going to plug it into either equation. It doesn't matter which one. I'm going to do 4x minus 3 times y, which is -1, equals 5. So I used this equation right here. Now, my -3 times -1 is +3. So I have 4x plus 3 equals 5. I'm going to get my 4x by itself by subtracting 3. When I do that, I get 4x equals 2. Now I divide by 4, and I get x equals 1/2, because 2/4, if you divide 2 by 2, you get 1, and when you divide 4 by 2, you get 2. So your solution is x equals 1/2. So my answer to this system of equations is my x value is 1/2, my y value is 1. So when I plug the point 1/2, 1, 1/2, 1 in for each equation, that both equations should turn out to be true in that situation. Are there any questions? So that is multiplying to do an elimination. So we can add, we can subtract, and we can multiply. Sometimes we do kind of need to multiply both equations, but we're not going to focus on that today. Okay. You're going to try this problem. So if you're doing this at home, pause the video. I'm going to pause right now, right here too. Let's go over this problem. Hopefully you understood how to do it. Should we add, subtract, or multiply here? Naomi says multiply. All right. We could multiply this by 4, so we would get a negative 4x. Yeah. Is that what you were thinking, Naomi? Well, what did you multiply by? So you multiplied the bottom one by 3? Did you multiply the top one by something too? Then you should have gotten 6y. Okay. All right. So we're going to keep our top equation the same, 4x plus 3y equals 8. And we're going to take our bottom equation and we're going to multiply by 4. So we did negative x times 4 is negative 4x. And you can see that's why we would multiply by 4. Good. So then we have the 2y, positive 2y times 4 is positive 8y. 13 times 4 is 52. I think, is that what everybody got out there, 52? Good. All right, so now we can take our two equations and add them together, because 4x plus negative 4x is 0x. And 3y plus 8y is 11y. And 8 plus 52 is 60. This problem turned out to be a little messy, I think. Am I right? Turned out to be a little messy. So we need to divide by 11, and we get y is equal to 60 over 11. And I am just going to leave that fraction just like that. That's going to be my answer. All right. So now, though, we need to plug that back into one of our equations. And to me, it looks like I'm going to go with this equation. So I have negative x plus 2 times 60 over 11 equals 13. And I said it got messy because of this fraction. That's having an 11 in the denominator, multiplying by 2 here, kind of icky. But, we deal with it. Fractions are numbers too. Fractions are numbers too, people. Let's care about them just like we do all those other numbers. I know you care about numbers. Don't lie to me. We have negative x plus, well, let's see, 2 times 60 is 120 over 11 equals 13. So now we have to isolate this negative x by subtracting 120 over 11 from both sides. And we're going to come right up here. So we have negative x is equal to, and this is the way I'm going to write it. 13 over 1, that's 13, minus 120 over 11. So are there questions about what I did there? So this makes a 0. That's why we're just left with negative x on one side. And then this 13 is right here, 13 over 1, minus 120 over 11. And the reason why I did that is because when I subtract fractions, I need common denominators. So I'm going to have to change this fraction into a denominator that has 11, into a fraction that has a denominator of 11. So we have negative x is equal to, and here's the way I'm going to do that. Let's pull up a calculator, bring in the screen here. Where is it? Oh, there it is. All right, so whoops. All right. So I'm going to take that 13 and I'm going to multiply by 11, and that will give me a fraction of 143 over 11. So this fraction is equal to 13. So I've just changed the way that it looks. I dressed it up in some different clothes, so now we can do this subtraction on the right-hand side. So now we have negative x is equal to, well, it's going to be equal to some fraction over 11, and we do 143 minus 120, and that is 23. And now we have a negative x here, which means we need to divide by negative 1. And that just means that we change the sign to negative 23 over 11. So our solution is the point, well, the x value is negative 23 over 11, and the y value is the value 60 over 11. And that is how we answer a question like that. Whoa, my screen's in the way. Sorry about that, folks. Questions on that? You might have some good questions here to ask so that anybody watching this from home could learn something new. Ask a question if you have one.